My name is Mayur. The title of my project is Fabrication of Mass-Sensitive Resonating Cantilever for Detection of Volatile Organic Compounds. Volatile organic compounds are emitted as gases from certain solids or liquids. VOCs as volatile organic compounds are generally known as are numerous, varied and ubiquitous. These affect environment and human health. It is necessary to keep the concentration of VOCs under limiting values. Hence, the presence should be monitored continuously. Chemomechanical sensors based on MEMS technology have been used to detect VOCs. These sensors undergo a change in mechanical property of a sensitive layer upon interaction with an analyte. The micromechanical structure, which is generally a cantilever, is attached to a silicon support. The freestanding cantilever is coated with a sensitive layer. There are two modes of operations, static mode and dynamic mode. The static mode consists of measurement of cantilever deflection upon stress changes in the sensitive layer. In dynamic mode, we excite the cantilever in its fundamental mode and measure the change in resonant frequency, which is analogous to mass sensitive devices. For detecting VOCs, dynamic mode is used. A polymer is generally coated as a sensitive layer. The polymer absorbs the analyte gas, its mass increases, which changes the resonant frequency. The design of the sensor is based on designing cantilever, which will be operated in its dynamic mode. N-type silicon on insulator wafer has been used. The fabrication process calls for 5 levels of masks. The first 3 steps ensure the development of strain gauges and electrical contacts. The last 2 steps define the geometry of microcantilever for front face and back face etching of silicon with DRIE. Some of the steps in fabrication process are as follows: wet oxidation followed by photolithography to make an opening in oxide to make the shape of gauges, boron doping to obtain strain gauges, aluminum deposition for creating electrical contacts, dry etching of the front face. Here, ion bombardment and chemical reaction act at the same time. This is called as Bosch process. Etching speed of 2 microns per minute at ambient temperatures can be implemented. The sensitive coating chosen is a polymer. The sensitive layer is chosen for its affinity with the gas species to detect and depends on partition coefficient K. K is defined as the ratio of analyte volume concentration in gas to analyte volume concentration in polymer. Polyetherurethane or PEUT is used to detect ethanol. It is easily polarizable due to the presence of aromatic units, which leads to the high partition coefficients with aromatic compounds such as toluene and alcohol. It is deposited as sensitive layer by spray coating with semi-automatic bench to assure deposition of layers is as reproducible as possible. The constraints are: the sensor design is based on dynamic mode of sensing, which can be used only for gas detection. This type of sensors requires short and stiff cantilevers to achieve high operational frequency. It is important to consider the effect of noise in chemical sensors. The modification of geometry has different implications in terms of the noise. Reducing the geometry increases the resonant frequency, which reduces the noise. But this can also lead to a decrease in quality factor, which increases the noise. These are the references. Thank you.